right, let's start putting this logic together. So here's what deductive reasoning is, right? Like to separate it from inductive, well, I'll get to that. Let's start with big ideas, okay? There's two things in this section. The two things are the law of syllogism, which simply says we can chain together individual conditional statements. We can put A implies B together with B implies C, and together we now get one flow from A all the way to C, okay? That's the key. We can put 10 conditional statements together to create a proof that leads all the way from A to M. We can put 100 together. That's what mathematicians do world all over, like pages upon pages of logic from one point to another to develop modern mathematics, computer science, physics, quantum mechanics. Okay, and then below that we can use conditional statements to know new facts. So once we've chained together a proof and we encounter an example of something, so we go, okay, this scientist or this mathematician proved that A leads to B, or A leads all the way to M. Okay, we got this proof. And then you go, oh, I just found an example where A is true. Well, using that conditional statement, that means this thing I didn't know, B, is actually true too. And that's how often mathematicians' theorems or proofs in the real world get applied. They encounter something in a similar realm and they go, wait a second, I think that proof over there might apply to what we're working on, and combining that using your example with this conditional statement, you can know new information. That's the big idea. It's a little hard to wrap your head around that law of detachment, that second one. So we'll do lots of examples here. Okay, so remember first though, inductive reasoning is just patterns and guessing. Yes, our species evolved because of it. That's how we learned from a toddler to now. We use it every day to predict what's coming next because, even I'm driving a car and I see a car and I go, well, in the history, that person's turning left. They have their blinker on. I'm predicting all of these things that will happen so I can have a safe and fulfilling day, right? Deductive reasoning, however, is chaining together infallible, always true conditionals to learn new factual information, right? Okay, big difference there. Facts. A absolutely leads to B always, or we prove that statement is false. And then that statement is false. There's no negotiation, right? That's the beauty of deductive reasoning. Okay, so first is law of syllogism, chaining things together. So it's simply saying, if I lead from A to B, and then I have another conditional that starts where we left off. So we go, oh, if A is true, then we know B is true. And separately, if we ever encounter B to be true, that means C must be true. We can just put those together. We can get rid of that middle B here and just say A leads all the way over to C. Okay, let's use it in an example here. So determine whether statement 3 follows from statements 1 and 2 by the law of detachment or by the law of syllogism, yada, yada, yada. So it's saying, can we get to here by using the first two statements? So here it says vertical statements vertical angles are congruent. Now that doesn't seem like a conditional statement, but really it is. You're saying if two angles are vertical angles, comma, then they are congruent. So it's actually saying if you find vertical angles, then they are congruent. That's the statement of vertical angles are congruent. It's just a shortened version, but that's the logical implication behind it, right? And then below it says, if two angles, so you have the clear if here, if two angles are congruent, comma, then their measures are equal. Well, yeah, we have A is vertical angles. Let's do it in a different color. This pink, it makes the eyes bleed sometimes. I just like pink though. Okay, so if vertical angles, then they are congruent. And here it says, if you encounter two angles that are congruent. That's exactly here. Then the two angles are congruent. So if two angles are congruent, then their measures are equal. So that's vertical angles leading to congruent angles. And then we have another one that starts at congruent angles and leads to equal measures, right? So we can just get rid of that congruent angles middleman and just say vertical angles leads all the way over to equal measures. So if two angles are vertical, then their measures are equal. So yes, that is valid by the law of syllogism. The answer was written already right there. But that's a somewhat clear example. I know that first one wasn't an if-then, so you got to really identify, investigate the logic, okay? And then we'll do more examples, don't you worry, okay? The law of detachment, right, is just saying if I have a conditional, and again, I wrote up here, it's using a conditional. It's actually saying I can use this in this scenario, right? A is true, and I know A implies B. So that means B must be true. Again, it's only for that example, though. You can't say it's a global rule. You found a square with sides 4, and you used a conditional about that to know new information about that square. But it doesn't apply globally necessarily. Okay? So, let's do an example here. Again, this one is saying, this one's saying the following is a true conditional. Determine whether each condition or each conclusion is valid based on, okay. So it says we have this valid true conditional statement. That's the following is a true conditional statement. Okay, so we got it. If a ray bisects an angle, so if it's the angle bisector, then it divides the angle into two congruent angles. Got it. Okay, that's the very definition of a angle bisector. And we're given the fact to that. And so notice we're given just a fact. Ray BD bisects angle ABC. Oh my gosh, look at what we have right above it. We have a conditional that says if it's an angle bisector, then we know a new information, which is it divides the angle into two congruent angles, right? So we can say, well, I have this fact, so that must lead us to this angle and this angle are congruent. And sure enough, that's what they wrote. Angle ABD is congruent to angle CBD. And so we have, that must be true by the law of detachment. I have a conditional, A implies B. I am told that A is true. So that then leads us to know, yes, B must be true by the law of detachment for this specific example, right? We're actually talking about the names of angles here. We're not talking about abstract if you encounter an angle bisector. We're talking about this picture, this ray BD in this picture, and then we use the conditional to know new information. That's how we're going to develop proofs. Just putting these two things together. We can chain together lots of logic, and then we can, in a specific problem with a specific triangle, say in this triangle, because of those conditionals, we now know a fact. We now know that these two sides are congruent because of that conditional statement over there. And that's the idea. Okay, now let's just do a bunch of examples. So write an example to illustrate the correct use of the law of detachment. Okay, so I love if it's sunny. Let's do something different, okay? So if I find a $100 bill, I will smile, right? Look at that, right? And so this is all number one, right? And then, I don't know, like on Tuesday, I found a $100 bill. Okay, so then what do we know? Yeah, that means, right, the if this, then this, and knowing that A happened on Tuesday, that means that then I know on Tuesday, I smiled. Right? We're using a factual example. I did find a $100 bill on Tuesday. That's a specific thing that happened. And I have a conditional that says, if that ever happens, then. And so now we know a new fact. A new fact is, I smiled on Tuesday. Hey, today's Tuesday, and I am smiling. Look at that. I did not find a $100 bill, though. Okay, number 2. Explain how the transitive property of equality is similar to the law of syllogism. Well, we haven't talked about what the transitive property of equality is, but it is actually something we're going to use, sort of. We're going to use the transitive property of congruence a lot. But all the transitive property is saying if we have, so if A equals B and B equals C, comma, then A equals C, right? So what this is saying is if these two things are equivalent and these two things are equivalent, then why have this middleman, right? A is the same as B and C is the same as B, so they're all the same. So then A is equal to B, or A is equal to C, right? So they are similar. I'm not going to write out the explanation, but the same thing is there's this middle step that we can take out to make it a more abbreviated, more succinct, precise term. Why say A is the same as B and C is the same as B when we can just say the beginning and the end result of that long chain are the same? And that's really what the conditional is doing, right? It's the same thing. Why take all these middle steps to get across the river? If we know that they're all linked together, we can just say A leads directly to C. Okay? let's find an error here. Okay, so an article in a magazine states that if you get seasick, that's our A, then you will get dizzy. That's B. Okay, so we know A implies B. And it also says that if you get seasick, so that's A, then you will get an upset stomach. So I'm just going to circle this part and call this is a new thing, so I'll call it C. And we also know A implies C. Whoa, that's a C. Okay? Suzanne says that this means that if you get dizzy, so that's if B, then you will get an upset stomach. So then C. So she's saying A to B and A to C means that B implies C? What the heck? That's not a thing, right? Like, so just saying that A leads to two different consequences has no relation between these. Yes, if A is triggered, then both of these are triggered, right? Like A, B, and C are both true, and they're both true at the same time. However, if A never gets triggered, what's the relationship between these? We don't know, right? Does B always lead to C? No, who knows? That's a totally separate question. So that's not a valid use of the law syllogism here. Those two don't chain together. This is A leading to two separate things. It should have been B here, and then we would have known A leads to C in this large chain. Okay, so that was the error. Okay, let's go to the next one. So determine whether the stated conclusion is valid based on the information. If not, write invalid. Explain your reasoning. Okay, so we're given this, if two angles are vertical, then they are congruent, okay? So we're given vertical. Hey, hot dang, that's A, right? That's our if A, then B. Oh, well then we know the angles are congruent. So angle A, angle B, that's the congruent symbol, check. This is law of detachment. This is valid. Check. Got it. Okay, let's look at the second one. If we have an example of C is congruent to E, well, that's the example of their congruent. So that's B. It's saying, then do we know A is true? So do we know that the flow of logic goes in reverse? We do not know the flow of logic goes in reverse. Now, separately, yes, we know that vertical angles are congruent as a biconditional. We could prove... no, what am I talking about? That's not a biconditional. Forget what I'm talking about. That's not biconditional. Just because we have two angles that are congruent, that does not mean they're vertical. Just ignore me. This is a perfect example of a specific to a general, right? So here's vertical angles in the set of all congruent angles. But there's lots of congruent angles out here that are not vertical. Sure, any vertical angle is congruent, but there's lots of other congruent angles just floating around in space, all these pairs that are the same size that are not vertical. So no, that reverse condition is not true. And definitely from this original if-then statement, no, we only know the forward logic. We do not know the converse is true. So this is invalid, okay? Use the law of syllogism to determine whether a valid conclusion can be reached. If not, just write nope. Okay, so if A, okay, so we got this, you're 18 years old, then you're in college, okay, that's your B, and then it says you are in college. Oh, well, that's really close to the law of detachment, right? So if they had told us you're over, or you are 18, if they told us you are 18 years old, then you would know you were in college. That'd be an example. Like if they said Joe is 18 years old, you go, oh, Joe's in college, right? If they said Susie, whatever. But that's not what they told us. They told us the end result. And again, we do not know if the converse is true. So no conclusion there. Converse, not necessarily anything to do with this statement. All right, and then let's do this one. The midpoint divides a segment into two congruent segments. So this is if midpoint, okay, then it divides a segment into yada, yada, yada. That's our B. Okay, so we got A implies B. And then it says if two segments are congruent, okay, that's B, then their measures are the same. So we have an A implies B, and we have a B implies C, right? So we have midpoint. So if it's a midpoint, then this is the two congruent segments. And then the next statement says if, and we start right there. We say if we have two congruent segments, then we get new thing. So we can, yes, If a valid conclusion is possible, write it. So we'll just write it the way they did, right? And so we'll stop here. So the midpoint divides a segment into two. Let's stop there. Segment into two segments with equal measure. Right? Or you could have done that as a if statement. So if midpoint, then two segments of equal measure, right? But yeah, this is absolutely right here, law of syllogism. Exactly a perfect example of it. Okay? Let's do some more. Determine whether statement 3 follows from statements 1 and 2 by either of the two. Okay, so let's do this. So I'm going to switch colors here. Let's just go for green. Let's go for light green. Okay, so if Molly arrives at school at 7:30, then she will get help in math. So here's the A and here's a B. And that says if Molly gets help in math, oh, that's our B. This is looking good. Then she will pass her math test. C, whoa, how was that a B? What the heck happened there? So yeah, that's a law of syllogism. We haven't even read the last one, but we can use the law of syllogism. Maybe they misused it, but let's try it out. So if Molly arrives at school, yup, then we can skip the middleman and we should end up at the C. Then she will pass her math test. Yup, check, valid. Whoa, what did I do there? Valid. Boom. Okay, let's do the next one. So right angles are congruent. So this is an if, right angle. That's all right. Then they are congruent. That's B. And then we have an example of congruent. Shoot, dang, that's the example of the conclusion. Again, we don't know that the converse is true. So no, not valid. Oh, so sad, right? So again, if we have, that's like here we have a pair of right angles. And here we have all congruent angles, right? Yes, sure, if we have two right angles, they're congruent, but there's lots of other congruent angles, like vertical angles, that are not congruent, right? So we don't know the converse that's true. In fact, we know it is not always true. So no, not valid. If they had told us that these are right angles, then we could go, heck yeah, we know they're congruent. That's the law of detachment. But they did it in reverse. They told us the conclusion was true. Okay, let's just do a couple more examples here. Let's see. Determine whether whether the conclusion is valid based on the information. Okay, let's do it. Let's stick with green. So it says if 3 points are non-collinear, then they determine plane. Oh, that's factual. Yeah, if we have 3 points that aren't on a line, a little triangle, that boom determines a plane in space. So we have 3 points that are non-collinear. Boom, they determine a plane. Yup. That's the law of detachment. We have a specific example of 3 points that satisfy this. So then those 3 specific points must satisfy this. Yep, that's a true example. Then it tells us E, F, and G lie in plane M. Well, that has nothing to do with our if 3 points are non-collinear. So get the heck out of here. We don't know anything, right? Oh, they lie in a plane. So who cares? That's nothing to do with our statement. So let's look at what they said. They're non-collinear. No, they could lie in plane M and be on the same line like that. They're all on a plane. Not only are they on the plane, they're on the line too. So not valid. Oh shoot, there's one word we could have wrote invalid. That's nice. Let's just invalid. Okay. P and Q lie on a line. What the heck? Again, this has nothing to do with us. So no, we cannot do this. So P and Q determine a plane. Invalid. That has nothing to do with our statement, right? We have to satisfy this original statement to lead to a valid conclusion. Down here, oh, see what they did there? A little tip of the hat. The triangle XYZ, that's the symbol for a triangle. So they said, we've given triangle XYZ. Well, what does that mean? For it to form a triangle, it can't be on the same line. If they were on the same line, why, that's not a triangle. I mean, you could loosely say like, well, it's a triangle rotated in space and we're looking at it two-dimensional. What the heck are you guys talking about? That's not a triangle if they're collinear XYZ. And so if they form a triangle, then they have to be non-collinear. So they gave us a really clever way of saying that they're not collinear. So yeah, then we do know those 3 points determine a plane. Yeah, that's the law of detachment. Exactly. A really nice, beautiful example. I liked that one. Okay, last little set of problems here. Use the law of syllogism to see whether we could get a valid conclusion. Okay, let's see. If you spend money on it, ooh, what's it? I'm excited. Then it is a business. Okay, all right. If you spend money on, what the heck? We're starting back at A. This is not going to help us. Then it is fun. No, this is, well, I put the same letter there. This is just A leads to B and A leads to C. That's interesting, but no valid conclusions there. No conclusion. Okay, let's look at the next one. So if the measure of an angle is less than 90, that's A, then it is acute. Oh, that's good. Okay, so we got an A to B. And if an angle is acute, hey, look at that. So we're starting with that B. So this is going to chain us somewhere. Then it is not obtuse. Boom. Not a very exciting, but yes, we could write if measure angle less than 90 degrees. This is a really shorthand way of saying it. Not obtuse. Right? So that's the shorthand way. You should write it out better. But I just couldn't fit it with my crazy monkey paw writing I've got here. Okay. Let's do another one. So if X is the midpoint, so X is the midpoint of a segment, let's switch colors just because we're doing so much here. So let's call this A, okay, and then of YZ. Then this is true, that's B, so YX equals. So if the measures of two segments are equal, so see they worded it different, but look at that. These segments are equal. Right? The length of those two segments. That is the measure of the two segments. The length of the two segments are equal. So they did cleverly. It's like a sort of B. It is the same, but it's phrased differently. Then they are congruent. So yeah, even though it looks a little different, yeah, you can. That's saying, so if X is the midpoint, then, and what you would say is YX is congruent to XZ. Right? So it's just taking this specific example that's equal and then saying that's congruent. Oh, it's almost like we did a law of detachment in a law of syllogism there, because we did link them together, but we had to use this specific example of equal to lead to specific example of congruent. So I would even call that a combo. Nice little boom, boom, 1, 2. Okay. And then last one. So we got if two lines intersect to form a right angle. Okay, so that's our A. If two lines form a right angle, then they are perpendicular. That's good. And lines L and M are oh my gosh, it's that same thing over and over. They keep giving us the conclusion. We cannot go backwards with the converse, so no valid conclusion for this last one. Okay, you guys, I hope you enjoyed that video. We are starting to birth logic into this course. We're starting to build and construct. I wonder what you guys will create.